Hello, ladies and gentlemen. Welcome back to another fascinating episode of Mrs. K's Flipped Classroom Algebra Edition. I am your host, Mrs. Carrington, and today our topic that we are going to be looking through or learning about, I guess I should say, is graphing. We're still going to be graphing quadratics, you guys, but it's going to look just slightly different. Look at this, the way this is written now. We are graphing in what is called vertex form, okay? So this form that you see up here is called vertex form. The reason it's called vertex form is because when you look at this, or when you look, basically, you should be able to pick your vertex right off of what you're staring at, okay? So we always say that the vertex is going to be at the point HK. Now, probably a little bit more than what we need to start off with right now. So I'm going to kind of glaze over that very quickly, and I'm going to go on to the essential question. Make sure you get it written down. It just says, how can you describe the graph of f of x equals a times x minus h squared plus k? All right. And then again, vertex form, you guys, the definition, just f of x a equals a times, so again, vertex form, the definition, you're basically just rewriting the form. All right. Now, some of you might be looking at this and thinking, Cal, I feel like I've seen that before. And actually, we have talked about this a little bit this year already, very, very briefly. But when we were talking about absolute values, that's when you saw something similar to this. There was no squared up here, but with these two long lines, when we talked about absolute values is when you guys saw a little bit of vertex form. So just something to kind of, recall, and maybe you remember some of the stuff we talked about when we talked about vertex form, because that'll really, really help out with this graphing side of stuff today. All right. First, oh, good. Whew, got nervous for a second. Our first core concept, you guys, we want to basically be able to figure out whether a function is odd or even. Okay? So one thing I would do, if you've got some like highlighters or something, I would get them out just so that you got it, so you can highlight some parts of these core concepts. We are going to be able to tell that a function is even when, if we take negative x, so like instead of taking, f of 2, and we're going to plug 2 in for all of the x's, what we're going to do is we're going to take a negative x. We're going to plug it in for all of our x values that are in our function. And then what's going to happen is, if our function remains unchanged, that's how we know that it's an even function. And then on the flip side, if we go ahead and we plug a negative x in for all of our terms, and our entire function, okay, it has to be the whole function, turns negative, then it's going to be odd. Okay? So if we kind of read this here, a graph is symmetric about the origin when it looks the same after the reflections in the x-axis and then in the y-axis. Okay? And now, maybe that doesn't mean anything to you, and I get it. It's a lot of words. Show me the math, show me the numbers, show me the examples. So, let's do an example. Shoot, that went too far. Okay. Determine whether each function is even, odd, or neither. So taking a look at letter A, you guys, first step, like I said, we're just going to take all of the x's in our function, and we're going to substitute a negative x in for it. Okay, so instead of this positive x, we're going to change that to negative x. Now, when we multiply this together, our new function is going to turn into negative 2x. Okay, negative 2x. So all of a sudden, our function went from positive right here in this step to negative here. That means that our function is odd. Okay? So we went from having a positive function to all of a sudden having a negative function. It turned odd. Okay? Second example, same kind of thing. We're going through, we're going to plug a negative x in there. So I'm going to do, that's negative x squared minus 2. And then if we take that negative x and multiply it by itself, that actually stays. So we ended up coming up with the exact same original function, right? There was no change from this to this. So this time we can say that our function is even. Okay, then for letter C, same kind of thing. Let's plug a negative, whoopsies, negative x in there. So there's negative x squared plus, we've got negative x, I'm going to run out of room, minus 2. Made it. Okay, so here, this is going to stay, right? Because we have a negative x times negative x. That's just going to turn into x squared, positive x squared. So this 2x squared is actually going to stay the same. This is kind of the key part for us, this next spot here. That's going to turn into a negative x. Okay, so notice how, you know, this term didn't change at all, but this term changed. And that right there tells us that this function is neither even nor odd. Okay, so remember, an odd function means that all of the signs change. Even function means none of the signs change. And then neither would be, you know, if the signs are changing, like one sign changed, but one of them didn't, kind of thing, which is exactly what happened here. One of the signs changed, but the other two didn't, so all of a sudden that's got to be neither. Your task, pause the video, do 1, 2, and 3 on your own. I will give you the answers to these tomorrow in class. And then here we're going to get into more of the graphing side of things. Okay? So just a couple of things to look at. Number 1, this guy right here, right now for us, this is probably the most important thing that we want to look at. Your H value. H controls the horizontal. So maybe this is the little trigger that we needed. When we talked about that function, or that, sorry, the vertex form, when we were dealing with absolute values, remember, H was the horizontal. And maybe you remember some of this. Even though H is negative, that's going to take and move our function to the right. Oh, I wrote in the wrong color. I should have written in red. Because now all of a sudden, this is our new graph of that function. Okay, so if H is negative, as backward as it sounds, whenever H is negative, just because that's the way the formula works out, our graph is moving to the right. Conversely, if we have, and you know what, I'm just going to rewrite this because to me, that's just kind of tricky. Whenever we have a positive H, then this graph is going to move to the left. So again, it's backward. This is positive H, but it's actually moving to the left. Okay, again, keep that in mind. Highlighters are really, those are good things to use here. And then the last couple of things. The vertex. Your vertex is just going to be the ordered pair. Remember, vertex, ordered pair, vertex. We always write as an ordered pair. We always write the vertex as an ordered pair. Whatever your h coordinate is, whatever your h value is, okay, that's going to be your x coordinate, and then 0 is going to be your y coordinate. And then same thing, kind of over here, axis of symmetry is just going to be x equals your h coordinate, or your whatever you have as your h value. Okay, again, axis of symmetry, we always write as a line. We should always write that as x equals. Okay, I'm going to do 2 examples with you guys, and then I'm going to have you do the third one on your own. Okay, first things first, you guys. I'm definitely a list person, and I do a lot better when I have like certain steps that I need to follow. So I'm going to just kind of outline this for you because I don't feel like I did a very good job of this the first time I explained graphing quadratics to you. Here's a basic template that you should be following every single time you go to graph. First off, find your axis of symmetry. Okay, that's step 1. It might be, remember when we have quadratics in the form of ax squared plus bx plus c, then you're using the formula x equals opposite b over 2a. That's not this. Okay, you do not need to use the formula opposite b over 2a because we don't have an a term, b term, or c term. Now we're dealing with a, okay, so I guess we do have a. But we have a, h, and k. Okay, second step that I want you guys to write down, just on the left-hand side underneath where it says questions on your thing. Second step, you are finding a vertex. Okay? Your vertex, remember, you always write a vertex as an ordered pair. And then third step, you are going to find 2 other points to graph. Realistically, ladies and gentlemen, you only need 3 points to create a quadratic graph. Only 3. You need your vertex, and then you need 2 more that will help you develop the shape of the graph. A lot of times, I'm going to steer you in the direction of trying to find the y-intercept. That's probably going to be one of the 2 points that I ask you to find because it's super easy to find the y-intercept a lot of times. And then the second point, you're just going to use the symmetry. Okay? Let's do this example following these 3 steps. First off, axis of symmetry. Remember, it's x equals your h value. So right now, we have g of x equals a x minus h squared. Okay, your h value is 4. Remember, this is opposite of what we think. Your axis of symmetry is going to be at 4. So I'm going to go 1, 2, 3, 4. And I'm going to draw that dashed line in here. Step 2, your vertex. Okay, think back to this last slide. Your vertex is going to be your h coordinate and then 0. We just figured out h is 4. So this point is going to be at 4, 0. 1, 2, 3, 4. 4, 0. Right here on your x-axis. Step 3, you need 2 other points. Super, super easy one to find is your y-intercept. Okay, I'll do this in red. The reason it's so easy to find your y-intercept, you guys, is because you're just taking 0 and you're plugging it in. Right? Because right here, this is x is 0 at this point right here. So you're finding where it's crossing this y-axis. So if we take 0 and we plug it in, we've got 1/2 times 0 minus 4 squared. Okay, so g of 0 is going to be, let's see, so this would be negative 4 squared. Negative 4 squared would be 16. Half of 16 would be 8. So you have a point at 8, 0. Or excuse me, 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right here. Lastly, through symmetry. And I believe for you guys, this is going to go off the graph just slightly. I couldn't find a big enough graph for this. You are just going to take, and through symmetry, you've got another point. This point is 4 spaces to the left, right? Same thing, we're just going to do the exact same thing here. 1, 2, 3, 4. That's symmetry. That's the way it's supposed to work. Parabolas are symmetric. And then here's our graph. Remember, always do the arrows because that signifies that the graph is continuing on. You guys, that's all there is to it. There's really not that much more to it. Okay? All right. I will, whoopsies. I will do number 4 with you guys, but then you got to do number 5 on your own. Okay? So, number 4. Remember, let's follow our steps. Number 1, symmetry. It's an x equals something. We want to find, okay, so here's g of x equals ax minus h squared. This is our h value. Notice how it's positive 5. Look at your formula, or your formula. Your formula has a negative here. This is a different sign. So your axis of symmetry is going to be at negative 5. 1, 2, 3, 4, 5. So I'm just going to go ahead. I'm going to draw this axis of symmetry in here while I have my pen red. Step 2, find your vertex. Always list your vertex as an ordered pair. Okay, now remember, your vertex is just your h coordinate, comma, 0. Oopsies. Oh well. Okay. So I'm going to plot that point. There's my vertex. Third thing, I've got to find 2 points. One of them that's really, really easy to find is your y-intercept. Go ahead. Find, sorry, this is going to look weird. G of 0. Go ahead, plug 0 into that function. Plus 2 times 0 plus 5 squared. 5 squared is 25. 25 times 2. Okay, yeah, that's going to be 50. So that's going to be at 0, 50. Probably not a great one for us to do right now. But the beauty of this is right now is that we actually have not decided what our scale is over here. So let's just kind of make up our own scale then. So 10, 20, 30, 40, 50, okay? So 0, 50. Okay, now we can find that second point. Let me just change this color really quick. Second point, so that's 1, 2, 3, 4, 5 to the left. Excuse me, 5 to the right. So we're going to go 1, 2, 3, 4, 5 to the left. Okay, so you're probably going to have to adjust your graph on your paper. But this is just a super, super, super wide one. Your job. Pause the video. Actually, this video is going to stop because this is all I'm going to do on this video because it's getting a little long. You're going to do number 5. I will go through number 5 with you tomorrow in class so that we have the basic idea of how to graph these. Okay, thanks for watching. I'm going to go ahead. I'm going to make the second video, so make sure that you finish this up and then you play the second video.